Our project is experimentally determining the Darcy friction factor of a PEX pipe setup. And this is by David Schwartz, Nick Viduya, Sam Hunn, and Tim Porter. The goal of our experiment was to experimentally determine the Darcy friction factor for water flowing through a PVC pipe in a gravity-fed setup. The defining equations that are used for this experiment are the energy balance equation with losses. These include major losses from friction and minor losses from bends in the pipe, valves that we added, and entrance and exit flows.
So for our test setup, we made a preliminary design. We were going to try and use a 5-gallon bucket hanging over the lab table with our PEX pipe coming out of the bottom with a ball valve. Then it would go down about 80 centimeters, go through a 90 in the pipe, and then straight out into our large storage bin, which would be sitting on top of our load cell so that we can gain the data we need to continue with the experiment. So here's some pictures of our actual test setup. Again, we weren't able to use the lab table, so we moved to a lab bench, but we had the 5-gallon bucket, our PEX pipe with a valve, which can be seen there, the blue handle. Then it continues down and hits the white 90 and goes over into the storage bin, which is sitting on top of our load cell connected to our computer, which will be collecting the data.
So in this project, we used a variety of different sensors. The first sensor we used was a set of calipers. This was to measure the inner and outer diameter of our pipes in our system. Secondly, we used a ruler. This ruler was to measure the vertical and horizontal distances within our system. Finally, we used an Arduino scale to track the mass output of our system. We use this mass output over time to find a mass flow rate, and using known values of the diameter of the pipe and density of water, we're able to calculate a flow velocity from that weight. Some of the components we used were PEX pipe. We used push fit valves and 90-degree elbows. Additionally, we used a 5-gallon bucket as our reservoir, and additionally a storage container to collect the fluid output on the other side of the system. So some of the pros of our system were that this closely replicates the assumptions we made in our preliminary design. But one of the cons is that the piping in our system that comes off of the bucket didn't really have any structural support. So there was nothing ensuring that it was perfectly vertical and perfectly horizontal in the given sections. That could have an effect on our answer just because that's an assumption we made in our preliminary design. So some improvements would be that we could make a more rigid test setup to ensure that the pipes are oriented correctly. We could also increase pipe lengths, which would decrease the impact of inaccuracies associated with the minor losses in our system. Another thing we could do is use industrial grade pipes to better match our assumptions. And finally, we could increase the size of our reservoir to reduce the change in water level during tests. So these were our measured mass flow rates. We did 3 different trials. As you can see, there's very little variation between the trials, so we were very pleased with this result.
So from our collected data from the experiment, we were able to find our experimental results. From the load cell and timer, we found a velocity of 1.7 meters per second. And then from the caliper and roller, we found other dimensions from the system, along with some tabulated values to get a final Darcy friction factor of 0.0966, which is around what we expected for our system.
So one of the important topics of measurements 2 and engineering in general is conducting a formal design of experiments. When running tests, there could be several different variables that affect results. So a design of experiments can be utilized to test the combinations of defined variables to better understand how each of these variables impact the results. So for our given test, we show a formal design of experiments that could be completed to understand how the pipe material, height difference, and fluid type affect the Darcy friction factor for the given system. We cover all combinations of variables as shown in trials 1 through 8. And while we have the design of experiments displayed below, we didn't actually have the time and resources to complete the 8 trials. But in general, design of experiments will be a valuable way to test the variables and draw conclusions based off the combination of variables for different tests.
Yeah, so that concludes our presentation. Given that we're all graduating seniors, we would love to connect with our professors on LinkedIn. Please connect with us. Thank you for a great semester.
Thank you.
Thank you.